4.5 billion years in the making. A land as old as the Earth itself. Australia. It's not the brave new world you might expect. When Europeans first arrived in Australia, everything was new and different. There were few ancient relics, no old buildings, and little obvious history. They saw it as a young country, a kind of separate creation. Nothing could have been further from the truth. The oldest, flattest, driest inhabited continent on Earth is a puzzle put together in prehistoric times. And the clues that unlock the mystery can be found scattered across Australia's sunburnt face. My name is Richard Smith, and this is an amazing country. For a scientist like me, every rock has a history, every creature a tale of survival against the odds. If you've ever dreamt of exploring the Earth's deep history, Australia has got it all. So join me and spend a few billion years on the big island at the bottom of the world. It's a great place to get the big picture. Of all continents on Earth, none preserved the great saga of our planet and the evolution of life quite like this one. Nowhere else can you so simply jump in a car and travel back to the dawn of time. The best way to understand the story of Australia is to get out into it. Feel the sun beating down on its ancient bones. And I do mean ancient. To get a true appreciation of how long ago Once Upon a Time really was, you need to get a sense of deep time. Okay, so this looks like a pretty ordinary four-wheel drive. But imagine just for a moment that it's fitted with a deep time drive. I simply dial up the time I want to go to, and by the magic of time-shifted GPS, it does the rest.
You have selected the beginning.
I set the controls for 1 million years per minute. That's 60 million years of history for every hour we travel down the road. You want to see the real old Australia? It's quite a ride. At 1 million years per minute, a blink of an eye sees us in an Australia before Europeans. A few seconds later, and we pass the first Aboriginal footprints. Within minutes, you're dodging wombats the size of hippos and goannas as long as buses.
Caution, hazardous wildlife.
Worried about roadkill? It gets worse. An hour hour down the road and suddenly the land is dominated by dinosaurs. It will stay this way for the next 3 hours as we barrel back deep into the past.
Recalculating deep time.
Over 250 million years down the road of time, about 4 hours at this speed. And it's the world before dinosaurs. Even further, and there is no life on land at all. I drive on. At 500 million years, about 8 hours since we left the present day, all life is underwater and distinctly weird. But time is deep. There's still 90% of history to go. While the entire history of humanity occupied only the first few seconds of this journey, and complex animals the first 9 hours, I have to travel back over 2.5 days at this speed to reach the first stirrings of life.
Caution, destination approaching.
Finally, after over 3 days travelling at 60 million years an hour, I've driven back 4.5 billion years. I've run out of road. We have arrived in the darkness at the edge of time. When the first rays of the newborn sun shone out into space, they illuminated a scene of untold cosmic violence. Swirling around the young star was a disk of dust and debris. Every fragment locked in mortal gravitational combat with every other lump of rock, metal, ice and dust in orbit. This is the process of gravitational cannibalism that marked the formation of all the planets. And the Earth grew bigger and hotter with each conquest. The heat came not only from collision, but from the natural radioactivity building up inside. Then, just as the outer crust was beginning to harden, it's thought our planet was almost wiped out. Another competitor, this one the size of Mars, crossed Earth's path. The aftermath was the formation of our pale, airless companion, the Moon, and the red-hot, iron-rich ball of rock we know today as home. Understanding the fiery birth of the Earth really helps explain how the engine of our planet works. The crust I'm sitting on might have cooled down, but the planet below all of us is still a hot ball of rock spinning around in cold space, and it's still trying to cool down. And as long as it cools, the continents we sit on continue to move. This is the engine of plate tectonics that's driven the story of our world since day one. And for Australia, we can pretty much date that first day. Nearly 2,000 billion sunrises after that first dawn, I'm heading west to one corner of the country that has faithfully kept a record of the earliest days of planet Earth.
So we're almost there, just in front of us there.
For decades, geologist Simon Wilde has been climbing the Jack Hills in Western Australia, date stamping the early Earth.
And this is the famous Discovery Outcrop. It's the site where the world's oldest zircon crystals have been recorded.
Though ancient, it's not the rocks themselves that are so old here, but the microscopic crystals of zircon within them. Known in the gem trade as poor man's diamonds, zircon crystals form when molten rock cools in the Earth's crust. And just like diamonds, zircons are forever. If you ever wanted to find a spot to ponder your oneness with the great age of the Earth, you couldn't do better than this rock. Because within it are the oldest remnants from the early Earth ever found. Older than you and I by a mere 4.4 billion years. At just a whisker younger than the age of the planet itself, this tiny treasure, zircon W74, is the original little Aussie battler. Recycled from rock to rock, zircons like W74 have resisted everything the planet has thrown at them. And yet they've somehow managed to keep a diary of the earliest days, locked deep within their crystal lattice. Reading that diary in the lab has been a revelation. The oldest zircons, it seems, crystallised inside molten continental granite that cooled rapidly in the presence of abundant liquid water. Rather than remaining a red-hot hellhole for as long as first thought, the young Earth already had oceans, clouds and rain. Waves were probably breaking against the cooling shore of the future Western Australia within 150 million years of the Earth's formation. The sun has beaten down on this patch of land for as long as anywhere on the surface of the Earth. It's no surprise then that Australia feels like an old, tough country. Within a stone's throw of the Jack Hills is nearby Malura Station. Here, cattle farmer Patrick Walsh is the third generation of his family to eke out a living on the oldest corner of perhaps the oldest continent on Earth. The geologists are up there getting terribly excited, bashing on rocks and getting things.
Yeah, they're very excited. I always joke with them and say that that's the new G-spot in geology, because you get a good laugh out of it, and they, you know, it is important. You know, it did rewrite the geology books. That doesn't happen every day.
This new picture of the young Earth is of a place you would have recognised. A volcanic landscape rich in raw geology and poisonous fumes, but totally devoid of oxygen. If you were lucky enough to be able to travel back to the very earliest days of the planet, you would have been treated to some of the greatest shows on Earth. But you would have needed a lot more than a hard hat and a gas mask, because this was a very dangerous world. We can tell from the heavy cratering on the moon at this time that the early Earth must have been pounded to within an inch of its life. You can get a sense of what this must have been like by visiting Wolf Creek Crater in the Kimberley. Blasted out of the Kimberley landscape a mere 300,000 years ago, it's small by prehistoric standards, but perfectly formed. The great thing about Wolf Creek Crater is because it's so fresh, relatively speaking, it's a terrific place to see what sort of impact a big impact can make. When the object hit over there, it released so much energy that it set off an explosion the equivalent of an almighty nuclear blast. As the material came out, it literally flipped the rock back onto itself around the edges. This sandstone is now leaning back, and everything that was in there either vaporized or was hurled out into the surrounding countryside. But Wolf Creek Crater was formed by an object only about 10 or 20 metres across. Combine at least one 50-kilometre asteroid striking the Earth every century with a corrosive, acidic atmosphere, and you probably have the reason so little of the early days of planet Earth survives. The craters of the Moon show that the Great Bombardment slowed about 3.8 billion years ago. But while the Moon's face has changed little, the Archean Earth looked nothing like the world today. None of our familiar continents, no green blush of life on land. But dive into those ancient Australian seas, and you would have found the first stirrings of life. It probably looked like this: slime. Some of the earliest tantalising signs of what could be fossilised bacteria appear in Western Australian rocks around 3.5 billion years ago, not long after the meteor bombardment ended. While the details of the origin of life remain shrouded by the mists of time, scientists are starting to get a fix on when and probably where it happened. And one thing is for sure, the early Earth had plenty of the raw ingredients. A reliable supply of water, heat and biologically useful chemicals could all be found close to volcanic vents, like in these hydrothermal pools in New Zealand. This blistering water contains no oxygen. Instead, it's rich in poisons, like hydrogen sulfide and arsenic. And rich in life, too. The orange scum lining the rocks is a jungle of primitive bacteria and archaic microorganisms, all feeding on the noxious goodies oozing from the hot earth below. Similar environments have existed in the sunless deep sea for billions of years. Both habitats are home to the most primitive life forms we know, and both are closely linked to the dynamic tectonic world we now live on. Wherever it started, life soon took hold in the sunlit shallows. And to see what it looked like, we need to head to the beach. The Australian Outback, bone dry and baking hot, Hardly the sort of conditions you'd associate with the origin of life. But it's precisely because of this tough environment that down at the end of this road, we can find a unique glimpse into the world at the dawn of life.
If you ever wanted to pay a visit to your most distant ancestors, then Shark Bay in Western Australia is the place to do it. The high rates of evaporation here in Hamlin Pool make the shallow water twice as salty as the open sea. Just the sort of tough, preserving conditions for slow-growing old-timers who prefer to be left alone.
Meet your most distant living relative, the stromatolite, still going strong here in the salty waters of Shark Bay. Now, these guys might look more like rocks than your relatives, but you shouldn't be easily fooled. On the outside is a vast living community of microscopic bacteria that have developed the knack of gluing mud into mounds. And they've achieved this with the revolutionary trick of harnessing the power of sunlight.
Photosynthesis changed the world. No longer slaves to volcanic energy, light-harvesting bacteria began to spread to any sunlit surface in the sea. And growing as stromatolites, they could even make their own. It's the ultimate living rock. How the bacterial colonisation of those distant shores began is a puzzle that scientist David Flannery is keen to solve. And a simple living algal mat offers a remarkable clue.
It's much easier to interpret things in the fossil record if you have a modern example. Here's a piece of rock from Western Australia in the Pilbara. It's 2.7 billion years old, and it has a very similar structures, and it comes from a very similar environment. You can see the modern example is made up of these tufts and ridges and this polygonal pattern, and the fossil example is made up of the exact same stuff. You can see the same processes in play that were working billions of years ago on the surface of this planet.
They may come in a range of shapes and sizes, but these high-rise bacterial communities have barely changed in billions of years. To swim here is to take a dip deep into the past. This is a time tourist's trip to a 3 billion-year-old beach. We know that stromatolites dominated the ancient Australian shorelines because you can still visit them, preserved in the rocks of the Pilbara. The town of Marble Bar, population about 350 plus a few dogs, claims the dubious distinction of being the hottest town in Australia. It's probably why some joker dubbed this torrid little spot a few hours out of town North Pole.
Geologists can read perhaps the oldest preserved planetary landscape in the rocks here. A coastline with beaches and sandbars. And something else. The gentle laminations in these rocks have been interpreted as the first tangible evidence of life.
Visible to the naked eye, these may be the world's oldest fossilised stromatolites, dated to nearly 3.5 billion years. Though the biological origin of the oldest fossils is still hotly debated, The rocks of the wider Pilbara are clearly awash with once-living stromatolites that in places must have formed extensive coastal reefs. As far as we can tell, this was the Australian seaside circa 3,000 million years ago. Stromatolites in the shallows, smoke on the horizon, fire in the sky. These simple life forms made their mark on the world in a far bigger way than as fossils in a landscape. They started making the landscape themselves. South of North Pole lies another Pilbara treasure, Karijini National Park. I'm taking a shortcut to the distant past. The deeper I drop into iron-rich Hancock Gorge, the further back in time I travel.
Okay.
Down here, you can look back at one of the Earth's great turning points. Two and a half billion years ago, the atmosphere was still without oxygen. But beneath the waves, stromatolites and their photosynthetic kin were steadily releasing this reactive waste product into the water. It didn't get far. The oceans were full of dissolved iron left over from the planet's formation. Mix oxygen with iron, and you can guess the result. The oceans began to rust. Year after year, for hundreds of millions of years, the oceans rusted. Layer by layer of rich red ooze settled softly onto the deep sea floor.
Now this is what I wanted to show you. See these dark bands of iron? This is the so-called banded iron formation. Now each one of these layers represents a rain of rust that fell to the seafloor 2.5 billion years ago. And you can see these pale bands in between. Now nobody knows if this represents some kind of strange seasonality, but if you think that every one of these layers of rust represents a pulse of oxygen in the oceans, then what you're looking at is the planet breathing, the first breaths of the biosphere.
Today, that first biosphere breathes life into the Australian economy. The massive iron ore deposits of the Pilbara are the direct economic legacy of the rusting of the oceans.
It's not until you stand deep in the pit of an iron ore mine like Mount Whaleback that you get the true sense of the scale of the rusting of the oceans.
The hills here are literally made of iron. Every year, over 33 million tonnes of ore are mined at Mount Whaleback alone.
And this is the business. High-grade iron ore exposed to sunlight for the first time in billions of years. Bang it together, it sounds like metal. And this stuff is heavy.
All of this Australia's great wealth of iron because of a waste product pumped out by microscopic bacterial slime operating on an industrial scale in those ancient seas.
The empire of the stromatolites was without doubt the greatest in the history of the Earth. Forget the Romans, the Persians, even the dinosaurs. These humble bacterial mounds dominated the planet for over 2,000 million years, and they engineered its greatest transformation.
Once turned on, the oxygen tap could not be turned off. The formation of iron was just a phase the Earth was going through. After 700 million years of rusting, the oceans ran out of iron. And the oxygen had nowhere to go but up. Now, for the first time, oxygen started entering the atmosphere. It was to be the greatest pollution event in history. Without the oxygenation of the atmosphere, we wouldn't be here. Nor would the myriad species we share the planet with. There might have been a revolution underway, but there wasn't much for a time tourist to see. Or breathe, for that matter. With oxygen concentrations at only a 20th of today's levels, your first gasp would have been your last. Even geologists have found the second half of the Proterozoic a little dull. After all the earlier dramas, things got stuck in such a long geological rut that they've dubbed this period the boring billion. But it was quite a good time for continental construction. The hot planet below had been busy, pushing and welding together the ancient chunks of continental landmass that today make up most of the western two-thirds of Australia. These tectonic forces would do more than just build a continent. They'd fashion more of the great mineral wealth the country relies on as well.
Down bottom of the deep, the cave.
Kilometres, my goodness.
Yeah, well done, boys. Very good.
For over 120 years, miners have been descending into the dark earth here at Broken Hill in western New South Wales. They've been unearthing a massive body of lead, zinc and silver ore from as deep as 1 kilometre below the surface.
13, that's it. The other lot of ore passes.
I'm heading down into a man-made ant's nest. It's a world most of us never get the chance to see.
Not only is Broken Hill one of the most iconic ore bodies in Australia, it's probably also the richest deposit of zinc and lead on the planet. Little surprise then that so much effort has gone into digging this stuff up, and equally into finding out where it came from in the first place.
The simple answer, it seems, is the bottom of the sea. In deep water off the coast of the building landmass, the hot earth was at work again, spewing out blistering metal-rich fluids from titanic seafloor vents. Cooling rapidly on contact, a black snow of metal rained from the icy seawater. Eventually, squashed and squeezed, cooked and concentrated, this became the ore dug up deep below mining towns like Broken Hill and Mount Isa. A legacy of continental construction. By about 1 billion years ago, most of the wandering continents, including embryonic Australia, had been crunched together into a supercontinent called Rodinia. Fossil evidence points to some of the first seaweeds, sponges and embryos appearing at this time. Life was moving beyond bacteria. And just as it did so, it was nearly stopped in its tracks. Welcome to Snowball Earth. Unmistakable evidence from around the world points to two great waves of glaciation that locked the planet in the firm, icy grip that gave the Cryogenian its name. These were the most severe ice ages in the planet's history. The Flinders Ranges in South Australia seem a world away from a great global ice crisis. Yet it was here that clues to just such a calamity were first found. Paleontologist Jim Gayling sees hard evidence for cold climates in his old seafloor muds.
This is tidal rhythmic sedimentation. In other words, every single tide has been recorded as a couplet of layers. But the beauty of this, it's a complete record of tides for as much as 60 years. And that is unique for rocks that are 640 million years old.
These soft sediments settled on the seafloor with the precision of grooves on an LP record. Each band turning to the beat of an ancient tide. The fine, undisturbed layering of this tidal calendar could only have formed one way. With the seafloor protected by a ceiling of ice.
The seafloor was actually sealed off from waves and storms because there was an ice cover over it. We were almost straddling the equator, and yet this ocean was covered with ice.
This is what we think the oceans of our planet would have looked like during one of these events. Frozen solid from the poles to the tropics. Now this is the frozen Arctic Ocean north of Barrow in Alaska today. In a month or two, most of this ice behind me will break up and drift away. It'll come back next year. But just imagine if the ice set in not for a season, not for a century, but for 1 million years, or even 10 million years. It's very hard to imagine anything surviving such a cold, cold world.
But survive it did. It was plate tectonics to the rescue. Furious volcanic eruptions, it's thought, primed the atmosphere with greenhouse gases. And the Great Snowball was soon followed by the Great Thaw. As the ice caps melted, seas rose and flooded back across the land. But the world that returned had changed. Life had not only survived the ice-bound snowball years, it was about to flourish. The moment is caught in time, here in the Flinders Ranges. With a sudden shift to warm yellow rock, the so-called golden spike.
Now, so what, you might ask? Well, this is a really significant moment in Earth's history because everything down here is icehouse, the end of the great snowball Earth. But up here, the planet's returned to greenhouse conditions. But much more than that. At this precise point, 634 million years ago, we suddenly enter a world clearly inhabited by animals.
In a secret location in the hills not far away, Jim Gayling and his team have unearthed a whole section of seafloor. A tableau of life in the Ediacaran. These are some of the oldest multicellular animals to be found on Earth. So significant that their discovery near Ediacara in the Flinders Ranges has given the age its name.
So you're looking at a snapshot of life on the quiet bottom, just below the reach of waves during fair weather.
Here was a garden of strange animals. Frond-shaped creatures feeding in the current. Others resembling anchors and throat lozenges.
Now, the most common one is this little pancake-shaped thing, Dickinsonia.
Like a puffed-up placemat, Dickinsonia could reach about 1 metre across. It seems to have slid slowly over the seafloor, stopping from place to place to feast on the carpet of bacterial slime. One of the puzzles has always been, though, how did these creatures feed?
It probably crawled over the mats, decayed the mat underneath and absorbed the nutrients.
So no mouth?
No mouth.
What is certain is that there were things moving about on the seafloor looking for food. Tiny things, no bigger than a grain of rice, made these tracks.
What's this guy here?
Oh, yeah. Now, that's one of my favourites. It's Sprigina. And it's important because we see that there's a head end. It looks like a shield with a bulge behind that, which might just be concentration of its sensory organs.
So a brain, an early brain.
That's right. So the first smart creature on Earth, perhaps.
Maybe the last.
Sprigina was an animal on the prowl. A pioneer crawling into the record books right here on a long-lost Australian shoreline.
The record that we have here is of the first animals, the Ediacara, which could actually move and feed on the sea floor. And forever after, the Earth was going to change.
For the great bulk of the planet's history, we've travelled through a landscape where raw geology ruled the world and slime ruled the waves. And now, after nearly 4 billion years on the road, we've arrived at the end of the beginning. While life was starting to soften the planet's surface, Earth's underground heat engine had been busy driving Australia, Antarctica, India, Africa and Madagascar together into the famous supercontinent Gondwana. As the Gondwanan giant was shunted together, shockwaves rippled across the Australian mainland, pushing up a titanic mountain range, the Petermans, that once towered over central Australia. By the time the sun was glinting off their jagged icy peaks, it was also sparkling through into the first seas of the Cambrian.
There you go.
Thank you very much. A time-travelling tourist to Australia 540 million years ago would have been able to complete what is today an impossible journey.
Push it right over that side, mate.
Thanks, mate. You would have been able to board a ship somewhere to the north of Cairns and sail inland almost to the south of Adelaide. Mark the east coast of Cambrian Australia on a modern-day map, the coastline would have wiggled down from Cape York to finish up somewhere south of Adelaide. It's called the Tasman Line. This would have been the view to the east of the Tasman Line. Nothing but open sea. The entire eastern third of the continent hadn't been made yet. The eastern states of Australia, where they existed at all, were still mud at the bottom of a tropical sea. If you'd been able to gaze down into those warm, ancient seas, you would have seen that they were teeming with an abundance and diversity of life, the like of which the planet had never seen. It's been dubbed the Cambrian Explosion, a reflection of just how quickly animals took over the oceans at the time. There'd been strange creatures in Australian seas ever since the Ediacaran. But now, suddenly, things that might not look out of place on a seafood platter were scurrying over the sand. And one of the best places on the planet to meet them is Kangaroo Island. Here, the once undulating prehistoric seafloor has become rolling green pastures. Tucked away high above the waves of Emu Bay lies one of the world's premier Cambrian fossil sites. This is awfully good fun, but I have to keep on reminding myself that what I'm actually doing here is taking a half-billion-year-old rock, tapping it with a hammer, and coming face to face with perfectly formed little crustacean-like things that were scurrying around over 500 million years ago. These are trilobites, ancestral arthropods that made their grand entrance in Cambrian seas.
The Cambrian explosion was a time period in the history of life which is probably one of the most significant in Earth's history. We see animal groups that are recognisable today first appearing in the fossil record. So the arthropods, for example, things like spiders and crustaceans and insects, and the mollusks, another major group that we see today. They have their recognisable beginnings in the Cambrian.
There are so many trilobites found at Emu Bay. They must have been scuttling everywhere. The The gentle days of the Garden of Ediacara were over. This was a world of mouthparts and mobility. Hunters and the hunted. Armour-plated arthropods patrolled the seas, searching for easy pickings. They were bug-eyed and bristling with new technology. Astonishingly, some of their soft body parts have been exquisitely preserved. Here's looking at one of the world's oldest eyeballs.
Here's a decent-sized beastie, a trilobite called rollicking. Now you can see all its segments quite clearly, and you can see this beautiful head shield with these big spikes down each side. But if you look even more closely up here, you'll see its two antennae. Just amazing.
Growing longer than a man's hand, rollicking was the largest trilobite in these Gondwanan waters. But it was still well armoured with defensive spines. There was a good reason for this. Top predator in the Cambrian Ocean was a giant arthropod called Anomalocaris.
Anomalocaris is an animal that probably could have reached 1.5 to 2 metres in length. So this thing would have been fluttering around in the surface waters looking for probably other arthropods.
Clearly, the evolutionary arms race had begun. While the trilobites went on to reign for another 250 million years, Anomalocaris swam into oblivion by the end of the Cambrian, leaving no known surviving relatives. Meanwhile, with no botanical protection, the high peaks of the Petermann Ranges in Central Australia were wearing away. For 100 million years or more, rivers had been tumbling from their bare, snowy peaks. These days, the Petermann Ranges are little more than a fading blue blip on the Central Australian horizon. But their legacy lives on. As the ancient waters poured out of the mountains, they carried the raw materials for two of Australia's most treasured rocky landmarks.
The rivers that roared out of the mighty Petermann Ranges, which once towered on the horizon, swept their heavy load of worn-away mountain as far as the water would carry it. A lot of it ended up here to form the magnificent bedrock of Catajuta.
The smooth domes of Catajuta are the eroded remnants of a thick conglomerate of rounded river cobbles dropped by the fast-flowing water. A lighter load of sand was carried further afield. It ended up here, about 50 kilometres away, where rivers slowed as they met the shore. This is how Uluru, the great red rock in Australia's desert heart, began life. As wet sand from a recycled mountain range, settling at the edge of a now vanished Cambrian Sea. The lights went down on Cambrian Australia, with the stage set for the next great drama in the story of the Earth. And the cast was already gathering out to sea.
Despite the explosion of life going on in the sea, if you'd taken a walk on a Cambrian beach, you probably wouldn't have noticed much going on at all. Perhaps a trilobite might have tickled your toes, but apart from the wind and the waves, this was a silent world. There was still no life up there, on land.
It would not stay this way for long. The seas, now bursting with life, were set to spill their cargo onto the bare earth. And Australia was ripe for conquest. As our voyage towards modern Australia continues, life in all its terror and beauty clambers ashore. It's all aboard the good ship Gondwana as we sail further down the road of time. But our road ahead is a rocky one, with the course set for great triumphs matched against equally devastating tragedies.